Solutions are a special name for a homogeneous mixture. A solution consists of two parts: solute, the substance being dissolved; solvent is the substance doing the dissolving. Solution is equal to a solute plus a solvent. The universal solvent is water. Solvation is when solvent molecules surround solute particles to form a solution. It usually is an ion-dipole interaction. In general, there are 3 steps to form a solution. Step 1, or the enthalpy H1, is the expansion of the solute. Energy has to be inputted. The solute can spread apart to be surrounded by the solvent. Enthalpy 2, change in delta H2, is the expansion of the solvent. Energy is inputted again so that the solvent molecules are further apart by breaking or weakening the intermolecular forces, so the solute can be surrounded by the solvent. Step 3, or delta H3, is the formation of the solution. The solute is surrounded by the solvent particles. So the enthalpy of the solution is the enthalpy of the expansion of the solute and plus the enthalpy of the expansion of the solvent plus the enthalpy of the formation of the solution. Delta H1 and delta H2, energy must be inputted, so it's an endothermic process. The formation of the solution can be exothermic or can be endothermic, depending on the substances. Dissolution versus dissociation. Dissolution is another word for dissolving. If my solvent is water, my molecule or ions will be surrounded by the water molecule, so it's getting solvated. If I have sugar molecules such as glucose or fructose, when it's placed in water, it will dissolve. Each of these molecules will be surrounded by water. So for example, glucose contains HO bonds, which are hydrogen bonds. Water also contains HO bonds, which are hydrogen bonds. Towards the 8 of the glucose molecule, the more electronegative oxygen part of the water will be attracted. The O portion of the glucose will attract the least electronegative hydrogen of the water molecule. So the oxygen and the hydrogen of the water will orientate, so it will be opposite polarity. So in a dissolution process, we have glucose C6H12O6, which is a solid. We put it in water and it will dissolve and become aqueous, each molecule being surrounded by water. In dissociation, the solute will break apart into ions, cations and anions. If we have salt, NaCl, the Cl-, which is the anion, will be surrounded by the hydrogen, while the cation of the NaCl will be surrounded by the oxygen of the water, because opposite polarities will attract. So when you place NaCl in water, the solid NaCl will break into Na plus cation and Cl minus, which is the anion. Depending on the solution can also be non-electrolytic, weak electrolytic, or strong electrolytic. A non-electrolytic solution does not conduct electricity when dissolved. If I place a conductivity meter into a non-electrolytic solution, it will not light up. There will be no current. Example of a non-electrolytic solution is a sugar solution, because there's no dissociation of the molecules into its ion. Weak electrolytes conduct little electricity when dissolved into a solution. So when I place a conductivity device into the solution, it will light up slightly. Examples of weak electrolytes are weak acids and bases, because they only partially dissociate or break up into ions. Majority of the solution will be in acid or base form. Strong electrolytes conduct electricity very well when dissolved into solution, so the conductivity meter will be very bright. Examples of strong electrolyte are strong acids and bases because they completely dissociate or break into ionic compounds that are soluble in water. Strong solubility will also fully dissociate. Solubility measures the amount of solute that can dissolve in a given quantity of solvent. Substances that are soluble are solutes that would dissolve in solvent. Substances that are insoluble will not dissolve in substance and remain as a solid. Likes dissolves, likes will tell us if solution will form. We are talking about polarity. So polarity can be polar or nonpolar. So in general, if it's a polar and a polar, a solution will form. If it's a nonpolar and a nonpolar, solution will form. But if it's polar and nonpolar, there will be no solution. This is not possible. We follow the likes dissolve likes. Also, you need to understand what miscible means. Miscible means that the solute and solvent or multiple solutions can be mixed. Immiscible means they cannot be mixed. Solubility is also affected by the following three factors: temperature, pressure, and the type of chemical compound. For solids and liquids in general, with increasing temperature, solubility will increase. However, for gases, it's the opposite. There's a decrease in solubility with increasing temperature, because as the temperature increases, the substance gain more kinetic energy, so they expand more, they move around more, so it's more difficult to put them in solution. Also, increasing partial pressure of the gas above the liquid increases the solubility of the gas in the liquid. The three types of solution solubility are unsaturated, saturated, and supersaturated. Unsaturated means that more solute can be dissolved. So if I have a solution made up of water and salt, if I add another teaspoon of salt, it will dissolve. There will be no solid NaCl on the bottom of the beaker. If the solution is saturated, that's the maximum amount of solid dissolved. So if I add 1 grain of salt into solution, it will not dissolve. It will settle to the bottom of the beaker. If it's supersaturated, it can hold more than the maximum amount of solute. And you could do this by increasing the temperature. But these are very unstable. Once you slightly touch it, the solid will precipitate out. Solubility curve shows how much solute of a substance dissolves in water. The most important part of this graph is this vertical axis. It is the grams of solute per grams of water. It is not always 100. Sometimes it will be given as 200. Sometimes it will be given as 50. So make sure you realize how many grams of solute is dissolved per gram of water. On the horizontal axis, it is always temperature. Anything that is unsaturated is below the curve. Anything saturated is on the curve. Anything supersaturated is above the curve. So if I look at NaNO3, sodium nitrate, at temperature 40 degrees Celsius, at this point right here, it is saturated and it's about 105 grams of sodium nitrate per 100 grams of water. Anything below that right here, it is unsaturated. So if I have a point right here at 40 degrees and we have 70 grams of sodium nitrate, this is unsaturated. I could add additional 35 grams of sodium nitrate to make it saturated. If I'm over here above the curve, this is supersaturated. So that means the temperature must have been increased to dissolve more and then cool down to 40 degrees. This is oversaturated by 35 grams. So pause the video, try these problems on your own, and then check your answers. So how much SO2 will dissolve in 100 grams of water at 80 degrees Celsius? So we know it is all the solutes are dissolved in 100 grams of water according to the vertical axis. So at 80 degrees, we look for SO2, which is right here. So approximately 4 grams of SO2 will dissolve in 100 grams of water. What is the solubility in 50 grams of water at 50 degrees for HCl? So 50 degrees is right here. We're going to go up to HCl, which is approximately here. That is about 59 grams of HCl per 100 grams of water. Since they only wanted 50 grams, we need to divide this by 2. 29.5 grams of HCl per 50 grams of water. At 90 degrees, there is 60 grams of NH4Cl. So at 90 degrees, for NH4Cl, which is right here, we have 60 grams. 60 grams is right here. Is the solution unsaturated, saturated, or supersaturated? It is unsaturated, because in order to be saturated, you need approximately 73 grams of NH4Cl per 100 grams of water. Since we only have 60, we could add another 13 grams of ammonium chloride to make the solution saturated. Number 4, how many grams of 100 gram KNO3 per 100 gram H2O will precipitate out at 40 degrees? So at 40 degrees, we're here. We're looking for KNO3. KNO3 is the blue curve. 40 degrees, KNO3 is saturated at 65 grams of KNO3 per 100 grams of water. How much will precipitate out? So this is a supersaturated solution. So it's going to be 100 grams minus 65 grams, which is 35 grams will precipitate out. Pause the video, try these problems on your own, and then check your answer. How many grams of KClO3 can be dissolved in 200 grams of water at 90 degrees? So at 90 degrees, KClO3 is the pink one. So it's around right here. So that's about 50 grams KClO3 per 100 grams of water, because the vertical is in 100 grams. Since we are looking for 200 grams of water, we need to double this. So it's going to be 100 grams of KClO3 per 200 grams of water. 6. What substance is the least soluble at 10 degrees Celsius? So this is 10 degrees Celsius. Least soluble at 10 degrees is this pink one, which is about 5 grams per 100 grams of water, and that is potassium chlorate. Number 7. Why does the solubility decrease with increasing temperature for NH3 and SO2? SO2 is here, NH3 is over here. By just looking at the compounds, I can identify the bonds. If I look at the bonds, NH3 is hydrogen bond, SO2 is polar, so it's a dipole. So these are both molecular compounds. And we know molecular compounds are the weakest of all the solids. The other one that could also be included in here is also HCl. HCl is a dipole. If you notice, these 3 compounds, as the temperature increases, their solubility decreases. Since their bonds are so weak, what's happening is they're already becoming a gas. and solubility of gases in general decreases as temperature increases. The remainder of the compounds on the solubility curve are ionic compounds, so their bonding is much stronger than molecular, so their boiling point, their melting freezing point need to be higher to break the bonds, so they will remain at a solid for a longer time. So their solubility is going to increase as temperature increases. Which substance solubility remains unchanged regardless of the temperature? That should be NaCl. If you look at the curve, NaCl, it is pretty much a horizontal line. According to the graph on number 9, which substance solubility increases the fastest with increasing temperature? The one that has the steepest curve is going to be potassium nitrate. So that has an exponential curve, so that will probably increase the fastest even above 100 if we extrapolate the curve or the line for all of them. Extrapolate means to extend the line beyond the points so you can make other predictions. So for these solubility curves, you need to be able to read and interpret what is going on. Your biggest thing is please note what is written on the vertical axis. Is it 100 grams per water, which is the most common graph, but you might also see it as 50 or 200.